As we know, the MPLS protocol is used to help network devices forwarding the message according to the label information. So this part we will explain what is MPLS label and how to distribute the MPLS label by the LDP protocol. The MPLS label is short, fixed length, and locally signification identified. And the router forwards the packets based on the label information. And the label is located in the data link layer header and network layer header. And they are the information of the label. And the whole path, the whole length is 32 bits, only 4 bytes, compared with your IP header. Your IP header at least 20 bytes. So compared with IP header, it's very short. And the length is fixed. And it will be divided to become 4 parts. The first is the label, it have 20 bits. And the available range is from 16 to 104865. That means you have lots of label can be used. And from the label 0 to label 15, it has some special meaning. So if you have the distribute protocol like LDP, it can dynamically assign the label information, but the range is not from label 0 to label 15. And the next part, it has 3 bits long, used to execute the MPLS QoS, the quality. If in your MPLS network, you have different service, and then the service maybe needs different priority, different resources. So in this scenario, maybe you can choose the EXP part to indicate different values, different priority. And the next part is S, stack button identify. It has 1 bit, and we have 2 value, value 1 and value 0. And 8 means your label header will be directly close to your network header or not. So in the MPLS, you can use multiple labels. And the last 8 bits, we have the TTL value. The function is very similar like the IP header. If pass through one device, we will reduce the TTL value 1. The function is in order to avoid the loop, and also you can do some chess root function to make sure what's your first hop, what's your second hop, something like this. So this is a label. And about the MPLS label located in the link layer, data link layer, and also the network layer. So if this is the basic one of the link layer header and network layer header, between them, we can use the MPLS label, right? And in the label, we have 4 parts, the label number, the EXPS, and the TTL value. And the label also can be assigned to the packets using the S field of the label. Then you can use multiple labels. This is a very typical application for the VPN. So like this one, we have data link layer and network layer header. You can use 2 labels, and each label we will have 4 parts. But the S value, if the label directly connects with the network layer header, it will become 1. The rest of the label, the S value will become 0 to distinguish this is the last label or not. And then let's say the MPLS label identification. MPLS label located in the data link layer and the network layer. So according to the data link layer header, the type of value, different value will be used to distinguish different up layer protocol, right? For example, if we use the Ethernet frame and the encapsulation is destination MAC address, source MAC address, type, date, and some check field. And if we encapsulate the IP packets, IPv4, the type value will become 0800. If we use the MPLS unicast message, the value will become 8847. That means if you delete the data link header, the next part is MPLS. So your router must search your MPLS forwarding table. Then is MPLS multicast packet, and the value will become 8846. This is a multicast packet. So the type value will distinguish different upper layer protocol. And now we know the instructor of MPLS label. Then we have to know who will help us to assign the label, because only the network devices have the label information. Then we force the message out can according to the label forwarding plan, right? So one protocol we use is in our network, and the typical protocol is label distribution protocol, LDP. And the foundation of MPLS data forwarding is label switching. And the label switching were based on the different FEC, and by the default, according to the destination IP address. And not only about the LDP, but also the MP-BGP, RSVP, all of them can distribute the label information. And usually, the LDP can distribute the label for IGP routes and also for static routes. But the MP-BGP protocol is distribute label for the VPN v4 routes. And the MP-BGP also is a very big important protocol if you want to use the MPLS VPN. And RSVP distributes the label for MPLS TE packets. In this course, we will explain the LDP. And the LDP will use the UDP and TCP to encapsulate the packets. And also, this is a dynamic label distribution protocol. So very similar like the dynamic routing protocol, we have to find our neighbor. Then we have to exchange some information. And in this packet, we will exchange the packets. In this process, we will exchange lots of LDP packets. And these packets, some packets will choose UDP encapsulation. Some packets will choose TCP encapsulation. And the hello packets will use UDP and discover and also maintain the relationship by the multicast message. The rest packets of the LDP for session setup and also the label advertisement, we're using the TCP. And the special port number is 646. So if in your network, you add some filter policy, you must let the port number pass through. Otherwise, you will distribute the label unsuccessful. And then let's see the LDP packet type, because this also is a dynamic protocol to find the neighbor to exchange the label information. So we also have different packets. The first packet is a hello packet. This is used to find the LDP neighbor, and it will periodically send from the port with LDP enabled all the time. And the second part is initialization and keep alive packets. And this is used to set up and maintain the LDP sessions. And then is a label distribution packets. And this will use to ask the neighbor, please give me the labels, right? And also will advertise the label to the neighbor. And if some label need to be deleted, we also will use the label distribution packet to withdraw the label bounding. So this part is a very important part, and also includes the address and address withdrawal package, the label request, label mapping, label release package. So these are the different type. For example, now we already found our neighbor, and then I will show you how many labels I already assigned for my route. Please receive it, something like this. And the last type for the notification. The package is used to notify the LDP pairs if some important event in the session. For example, if we delete the configuration, we will send out the notification package to my neighbor. Please release everything because now I'm not working, something like this. And in the whole process, if we have route A and route B, first step, we have to discover a neighbor. We will send out the LDP hello package. And this package, we will use the UDP to encapsulate the message. And the port number is 646. And this package is a multicast package. The destination IP is 224.0.2. And the purpose is I will send out the hello package to you. I want to establish the relationship with you. So this is the first one. And because this is a multicast package, we only can be sent in the same link. So pay attention about this one. Then we want to set up a TCP connection because label is very important. It belongs to the control plane. We hope all the label information can be sent out successfully in the reliability. So we will choose a TCP. About the TCP connection, the port number is same. We will use 646. But the the transport layer protocol will already change to become TCP. Then we will set up a LDP session. In this process, we will send out some first session initialize. The master router will send out the package, carry some negotiation package, right? And then the slave router will check the parameter is ready or not. If yes, then we will send out the keep alive. That means the LDP session is ready. And the master router will check whether the parameters are accepted or not. If yes, I will give you a reply. So we will exchange 3 steps about the LDP session. Then we have to maintain the sessions. And how to maintain it? We will send out the keep alive message all the time. If some error occurs in this process, the TCP connection will be disrupted and the session will be closed. So we will detect all the sessions. And of course, if we establish the LDP session successfully, then we will distribute the label to show you what's the label map in my site. Please receive it, something like this. So in this process, we will find LDP use lots of packets to distribute the label. So in the future, some important protocol like the SR, we don't use LDP again because you need lots of resources to maintain the LDP session. Then let's see the details, some important packets. If we found our LDP neighbor, we will use UDP ports and multiple multicast destination IP address to find our neighbor. And who will be the master? Because in the process, we say the master will try to establish the session, right? The router with a bigger transport address is responsible for initial the TCP connection. And by default, the transport address is LSR route ID. And about the route ID, you have manually configured the IP address. And you also can use a command to change the transport address. The transport address must be reachable. because we have to use a TCP connection to help us force the message out. And here is an example. We will find the destination is 224.0.0.2, and the message type is hello message, right? Multicast. And here is a function. We will use hello packets to find our neighbor. And this is a route ID. So the process to find our neighbor. And then for the LDP session setup, we will use a three-way handshake to set up the TCP sessions. And the initial packets will be used to negotiate the parameters between different routers. And the two transport address need to be reachable. It is safe. And you can use the command MPLS LDP discovery transport address interface to set the special transport IP address. And here is one example. The message type is initialization message, and there are some parameters we must keep safe. For example, the version, all of them, the version is 1, and the keeper lifetime is 180. If after 180 seconds, you still cannot use still cannot receive the keeper live message, we will think our neighbor is broken, something like this. And then about the label advertisement, the address package is used to discover all the address of directly connected interface of the local routers. And the important is the label mapping package. We will advertise the local FEC and label binding relationship to all the routers for ourselves. That means if we receive one information, in our IP routing table, we have lots of routes, right? And this route we call is FEC. I will assign for each route one label. And this label relationship, I also will advertise to my neighbor. And this is a label mapping. And here is one example for the address message. And the address 123, this is a segment, directly connected interface. And lists the address of directly connected interface of the local router. And also we will use the label mapping to provide the label and FEC relationship. For example, for this segment 10.1.23.0, we will use the label for label 3, okay? And then let's see the process, how to get the label. And in this process, we will assign the LSR to become upstream and downstream along the data forwarding direction on the LSP to adjacent LSR as upstream LSR and downstream LSR. For example, if user A and user B, we have the segment 10.0.0 and 20.0.0. If now the packet direction from left to right, we want to wait the message to user B. First, the router receives the message we call is upstream, and the next router we call is downstream. Of course, compare with different routers. If between route A and route 2, route 1 and route 2, route 1 is upstream router, route 2 is downstream. But compare route 2 and route 3. Route 2 is upstream router. Route 3 is downstream router. And also, according to the direction, from A to B, route 1 is upstream. But if the traffic come back from B to A, route 3 is upstream. And the route 1 is the most downstream router. And why we need to know upstream and downstream? That's because different router will assign different labels. the label distribution process. If we establish the LDP session successfully, then the router will distribute the label according to your routing information. Finally, we want to create the MPLS LFIB. In the LFIB, the main parameters we have to know is in label, out label, and the egress interface. Of course, we still have the other parameters, but these three parts is the most important. And about the label are automatically and randomly generated by the router itself, less than 16. Okay, because from 0 to 15, the label have special meaning. And the other label, all the router will create automatically. Maybe you reboot the router, you will find the same FEC, but the label will be different. And the very important is we have in label and out label, right? And the in label are distributed by the local router itself, but the out label are the in label distributed by the downstream router. That means every router, for example, now if all the user A and user B want to wait with each other and by the MPLS label, right? First, they will have the routing information to the destination segment 20.0.0.0. This is the segment. And then if we use the MPLS protocol, then the three routers will create the LFIB, the MPLS forwarding table. And according to this FEC, everyone will create the in label first, in label. And this label also will create automatically. Some special. This is the ingress router for the for the destination 20.0.0. That means when I receive the message to the destination 20.0.0.1, this message will become the IP packets, not about MPLS. So this one we call is the most upstream router, the in label will be none. And the most downstream router, this is the egress LSR for the segment 20.0.0.1. If we send out the message to user B, I must delete the label. So I assign the label will become 3. This have special meaning. And the other router like route 2, or maybe between them we have route 4 or route 5, they will generate the in label automatically. For example, now the route 2 use 36 to become the in label for this segment. Then in the forwarding table, how to get the out label? The out label are the in labels distributed by the downstream router. So the process is now the most downstream router is R3. I already assigned the in label 3 for the destination. I will use the label mapping function, label mapping packets to send out the 3 to route 2. And then route 2 will use it to become the 3 to become out label. Also same for route 2, I will take the in label 36 to become out label 36. So out label will receive from my downstream neighbor. In label will create by myself. So this is a process. And if we get the forwarding table, how to force a message out, this is the next topic we will explain for you. And about this process, we call it a control plan to build a full LFIB. And in this process, we also have to add the next hop address, which interface we receive it. We will add the interface into the next hop and also to become out interface. Then how to distribute and management the label? We have some principle. The first is the local router can advertise label mapping message to its neighbor only after the label distribution. We have two functions. One is DOD and another one is DU. Downstream on demand, or maybe downstream unsocialized. And what's the different result? Later we will show you one example. And the local router can distribute a label to a root prefix only after the label of a location or not. We will have independent control or maybe ordered control. And what's the different one? The first is because the local router, after we assign the in label, we also have to advertise the in label to my upstream neighbor to become the out label, right? One is the first limitation is when I can send out the label. If my neighbor asks me, please give me the out label, then I will send to you. This is a request and the reply. Or maybe if I assign my in label, I will directly send to my neighbor. That means I don't care you request it or not. I will directly to show you. And the local router can distribute a label to a root prefix or not. That means all the local router can assign in label or not. Independent control or maybe ordered control, different type. Another is label retention in the process, where the local router retain all the label mapping message from neighbor in the data strip or not. Because in the MPLS network, maybe we also have multiple physical paths, right? So can we keep all the labels or not? This we also have two choices, keep all or maybe keep the best one. And the last is label space indicates the application scope based on interface or maybe global. We also have two choices, per platform or maybe per interfaces. So later we will explain one by one how to work of each part.